Hello guys, this is Moyuddin. In this video, we will talk about Amazon VPC, which is a really big and most important service of the AWS. This service offers many features, so I would be covering a few of them in this video, and the rest of the features would be covered in the upcoming videos. Now guys, before you continue watching this video, please make sure that you have watched my previous video on the IPv4 CIDR blocks so that you can understand this service better. That being said, let's get started. Amazon VPC stands for Amazon Virtual Private Cloud. It enables you to launch AWS resources into a virtual network that you have defined. This virtual network closely resembles a traditional network that you do operate in your own data center with the benefits of using the scalable infrastructure of AWS. So in a traditional network guys, you have bunch of servers, networking devices such as routers, switches, so that these servers can communicate with each other and to the internet, and then you have some storage devices like SSDs to store the data. Now with AWS guys, you get all these servers, these storage devices virtually, so that you do not have to manage any hardware physically, just like you do manage in your own data center. And with the Amazon VPC service guys, you can logically isolate these resources, and by the scalable means guys, you can anytime increase or decrease the number of EC2 instances, the storage devices you use, the routers, etc. Now guys, let me share with you a practical example, basically a real life scenario where you would need the Amazon VPC service. So let's say guys, you have a WordPress website deployed on Amazon EC2, and it has three environments: staging, development and production, and you have a different team to manage each environment. Now you do not want one team to access any team to access each other environments. Basically the staging team would have its own, you want staging team to have its own set of servers, and similarly the development and production team have its own set of servers. So for that guys, to logically isolate these three environments, you would use the Amazon VPC service. So now guys, let me take you to the Amazon VPC console to create our first VPC so that you can understand these concepts better. So guys, I have already opened the Amazon VPC service in my AWS account, and you can see that I am currently in the North Virginia region. Now let's click on create VPC. Let's name it as demo VPC. And in the IPv4 CIDR block, let's have a CIDR block of 10.0.0.0/16, and AWS has some limitations guys. The maximum CIDR block we can have is /16, and the minimum we can have is /28. So let's have /16. And here in the tenancy guys, basically when you launch Amazon EC2 servers, you have the option to launch the servers either into a shared server, or you can have your own dedicated server in AWS. So basically it is asking that in this VPC, when someone will launch EC2 instances, should by default the option shared servers would be selected or dedicated. So here we want the default one. Okay, so now let's click on create VPC. Okay guys, our VPC has been successfully created. If I just click here, your VPCs, you can see our demo VPC has been successfully created. And by the way, if you are wondering about this VPC guys, so basically this is the default VPC that AWS already creates when you create an account on the AWS. Okay guys, so now let's talk about another important concept of the Amazon VPC, which is the subnets. So what is a subnet guys? A subnet is a range of IPv4 addresses in your VPC. You can launch AWS resources such as EC2 instances into a specific subnet, and each subnet must reside entirely within one availability zone. So in simple terms guys, a subnet is a part of a VPC, and each subnet represents a single availability zone. So if I go to this awesome website guys, where we can just type our CIDR block, which is 10.0.0/16, click on calculate, and here it would tell us the number of IP addresses in that CIDR block. So here you can see guys, the total number of IP addresses we can have is 65,536, and here it is also saying us that the first IP would be this and the last IP would be this. Now guys, as I told you that a subnet is basically a part of the VPC. So now we have 65,536 IPv4 addresses in this VPC, and in this video I will create 4 subnets guys, and each subnet would contain 4096 IP addresses. So if for our first subnet, if I go here, click on subnets, and basically guys, all of these IP addresses that I am talking about will be basically part of this upper range 10.0.0.0/16. So if I click on create subnet, select this VPC, demo VPC, and here thus I just told you that for this first subnet we would have 4096 IP addresses. So how I would calculate that? So this is the CIDR block of our VPC, which has 65,536 IP addresses, and here if I type /20, then you can see guys, now this gives us the first 4096 IP addresses out of the 65,536 IP addresses. So here for our first subnet I would type that range here 10.0.0.0/20. and now guys, it's the perfect time to introduce you to the types of subnet. So basically we have two types of subnets. One is the public and the second one is private. So if a subnet is associated with the route table that has a route to an internet gateway, it's known as public subnet. And if a subnet is associated with the route table that does not have a route to an internet gateway, it's known as a private subnet. So guys, basically a public subnet is the subnet in which if we launch an EC2 instance and that EC2 instance has a public IPv4 address, then that subnet is called a public subnet. And if that subnet does not allow an EC2 instance to have a public IPv4 address, then that subnet is called a private subnet. Now let's talk about the route tables guys. So a route table contains a set of rules called routes that determine where network traffic from your subnet or gateway is directed. So basically guys, using the route table we instruct our VPC that if the instances should be allowed access to the internet or not. And here you would you have also see a term known as internet gateway. So what does this internet gateway do guys? So basically this internet gateway allows the EC2 instances to access the internet, and similarly we as a client on the internet access the EC2 instances guys. Okay, so now guys, let's create our first subnet and I would call it public subnet. So here that is guys a public subnet with that. Now please remember this CIDR block. Okay guys, so let's click on create subnet. Okay, so our first public subnet has been created guys, and here now guys, very strangely you may notice that here it says available IPv4 addresses are 4091. So why is that guys? I just said that it should have 4096 IP addresses. So where are the 5 IP addresses gone guys? So here is the answer guys. Let me show you the answer. So the AWS says that the first first 4 IP addresses and the last IP address, so in total 5, in each subnet CIDR block are not available for your use and they cannot be assigned to a resource such as an EC2 instance. For example, in a subnet with CIDR block 10.0.0/24, so in my example we have 20, the following 5 IP addresses are reserved. So basically the first IP address guys, which in our case is also 10.0.0.0, is reserved for the network address. The second one reserved by AWS for the VPC router. A third one reserved by AWS for the DNS server. The fourth one for future use, and the last one, guys. So the first 4 IP addresses and then the last one of the range is reserved for the network broadcast address. So that's why, guys, you only see 4091 IP addresses here. Okay guys, 4091. Now let's click on create subnet, guys, and create another subnet, and this time, guys, we will create a private subnet. So now let me click on create private subnet, and we have selected our demo VPC. So now, guys, here comes the most important thing. So now this subnet, I would select a different availability zone, guys. Let's say US East 1B. So now, guys, as you already know that previously we created this subnet, and in this subnet the first IP address was this and the last IP address was this. So the total CIDR block was of 10.0.0/20. And now, guys, let's say we also want to have 4096 IP addresses in our private subnet. So here now, basically I would take that last IP. So last IP was 10.0.15.255, and if you guys want to see the whole range of this CIDR block, just copy this, and this website I already shared in my previous video, and let's select 20 here, guys, list addresses. So here you can see the complete range of 4096 IP addresses, guys, and if I scroll all the way to the bottom, you can see the last IP address is 10.0.15.255. Now what should be the next IP address, guys? The next IP address would be 10.0. So the last one was what? 15.255. So next one would be 16.2.0, because after 255 we should again start with 0. So next one would be 0.15.16.0 and /20, which basically means we want 4096 IP addresses as well. So here now I would type 10.16. What did we write here? 10.0.16.0/20, and if I click on calculate, guys, okay, I think I did something wrong here, guys. So 10.0.16.0/20. Yes. So here you can see, guys, the first IP address is this one and the last IP address is this one. And here, guys, just to further clear your concepts, let me type the address of our IPv4 CIDR block, basically the VPC CIDR block, which was this. And if I click on list addresses, and here if I type 10.0. Yes, this one. So here you see, guys, this was the last IP address of our public subnet, right? And this is the next IPv4 address, 10.0.16.0. so that's why I started this next subnet with that. Okay, so that's the second 4096 set of IP addresses out of this 65,536 IP addresses range, guys. Okay, so now let me click on create subnet. Okay, guys, so this subnet has already been created. So if I go to VPCs and click on demo VPC, so okay, not here, let's go to subnets and select a VPC from here, demo VPC. So here you can see, guys, we have both of our subnets, public and private. So now, guys, let's go to the internet gateways. Click on create internet gateway. Let's name it demo internet gateway. So as I told you earlier guys, we use the internet gateway to allow our EC2 instances to have a public IPv4 address so that we can access them from our browser and they can have the internet access. So as you can see also here, an internet gateway is a virtual router that connects a VPC to the internet. To create a new internet gateway, specify the name and blah blah. Create internet gateway. So here our internet gateway is created guys, and we also have the option to attach it to our VPC, but I would not do that guys. So our internet gateway has been successfully created guys. Okay, where is that internet gateway? So here is our demo internet gateway guys. Okay, and right now it's not attached to anything, so let's click on attach to VPC. This VPC guys, attach internet gateway. Okay, so the internet gateway has been successfully attached to our VPC. Now let's go to the route tables. And here you can see guys, we have a route table with this ID, and here it says main yes. So basically guys, when you create a VPC, a route table is automatically created for you guys. So in this route table, if I go here and if I show you the definition again, what does a route table do guys? A route table contains a set of rules called routes that determine where network traffic from your subnet or gateway is directed. So basically guys, when we create a subnet, it is automatically attached to the main route table that is created when we create the VPC. And in this route table, you can see guys, we have option called edit routes. Let's click on edit routes, and here you can see guys that we have a route to we have options like destination, target, status, propagated. So in destination, we type the IPv4 address, basically the IPv4 CIDR block address where we want the traffic to go to, and there is the target. And here the local means guys that our private IPv4 EC2 instances that we will have a private IPv4 address using this range can communicate with each other using the AWS internal private network. So now guys, if I show you the subnet associations, so you can see guys that here we have subnets without explicit associations. So when we create a subnet guys, and if we do not have a separate route table for the subnets, then by default the subnets are attached with the main route table. So that's why guys, you see both of these subnets attached here. And now guys, as we want to have public and private both subnets, so for that purpose I would create a separate route tables. In one route table I would allow the internet access, and the other route tables I would not allow that subnet to have the internet access. So let's call it a public route table. And in the first I should type demo public route table. Select a VPC, demo VPC. Click on create route table guys. Okay, and now let's go to the subnet associations, and here you can see guys okay, so this is what so this is our route table that we just created. Now guys, if I show you the subnet associations, you can see that there are no explicit subnet associations, 0. So now let me click on edit subnet associations, and let me associate this public subnet with this our route table. So route tables, demo public route table, yes. So now you can see guys that our public subnet has been successfully associated with this demo route table. And now if I go to the main route table guys, you can see that in the subnet associations our public route table is not showing anymore. It's only connected with the private subnet. So that's what I just explained you guys. Okay, so Now guys, let's give this route table the internet access. So for that I would just click on this demo route table, scroll down, edit routes. So this is the local route guys. Now let's click on another route, and here we say that if traffic comes from any IP addresses except this range, if traffic comes from any range of IP addresses, then that traffic should be transferred where? To the internet gateway. And here is the internet gateway we just created. Now let's click on save changes guys, and boom. So now guys, if we would launch our EC2 instances in that subnet, you would see that these instances would have a public IPv4 address, and the IP and if we would launch the EC2 instances in the private subnet, that instances would not have any type of IPv4 address. So to show you that guys, let's go to the Amazon EC2 and let's create our EC2 server and let's see what happens. So let me go to the instances, click on launch instance. Okay guys, so let's click on public subnet server. Let's name it this one. Let's have this default Amazon Linux, whatever it is. Instance type is fine. Let's select this one. And here in the network settings guys, let's select the VPC we just created, and here you can see it is only showing two subnets, private subnet and public. So let's click on the public subnet guys, and okay, here it says auto assign public IP. We would say yes guys, enable. Let's not care about the security groups, whatever it is, and just click on launch instance. So okay guys, our instance has been successfully launched now. So here is our instance guys, and here you can see guys, when I launched that instance in the public subnet, it has been assigned a public IPv4 address. So now let's launch another instance guys, and this time we would select the private subnet. So let's click on private subnet. Okay, and instance type would be anything. Okay, fine. Just click on no. Here let's go to the edit network settings, demo VPC, and the private subnet is selected. Yes, private subnet. Click on launch instance. Okay, so select this one. So here you can see guys, let's okay, it's saying instance stays pending. So guys, here you can see that this instance does not have a public IPv4 address. Yeah, this public IPv4 address field is nulled, while our this instance which is in the public subnet guys, it has a public IPv4 address. Okay, public IPv4 address. So that's what the difference is between the public subnets, private subnets, the route tables. I hope you now understand why we use the route tables in a VPC. What is the purpose of the internet gateway guys? One last thing for this lecture guys, you may notice when the default VPC is selected, this option auto assign public IP is set to enable. But when we select our demo VPC which we just created, this option is set to disable. And for our VPC, EC2 instances to have a public IPv4 address, we must also explicitly set this option as enable. Now to avoid this guys hassle that each time you would have to explicitly select enable, what you have to do is this guys, that just go to your VPC, select your demo VPC that we just created, and select our public subnet, click on actions, click on edit subnet settings, and here guys, let's just select enable auto assign IPv4 addresses and click on save. Okay guys, so now guys, if I refresh this page, let's type whatever we want. Let's scroll down all the way to the network settings, and here guys, if you see that when I select demo VPC, and if I select this public subnet, because in the private subnet we do not want the IP4 addresses, let me select public subnet. You can see guys, this option is automatically set to enable. So that's what I wanted to show you guys. So I hope guys that after watching this video you have a clear understanding of the fundamentals of the Amazon VPC, and in the next video we will cover some other topics like NAT gateways and egress only internet gateway and some other stuff guys. So please make sure you stay tuned for that. And if you guys like this video, please make sure to give a thumbs up, comment if you have any questions, and please subscribe to the channel. Thank you so much.